using a graph, we got to use a different kind of skill set. All right? But I'm going to keep these graphs up here because I think this is really helpful, especially this one. As you guys can see in this equation, this graph continues going to the left, continues going to the right. If you were to randomly pick a number for x, is there any reason for you not to believe that this graph would not have a value or a point at that value? Think of like x is 300. Is this graph going to keep on going and then have a point when x equals 300? Right? There's no reason for us to believe that any number for x in our domain is not going to have a point on this graph, right? Because it extends indefinitely. So when you're trying to determine the domain using a function, the best thing to do is think about what prevents us from, what can prevent a point from being in the graph, or what can prevent a point from being in the function. And let's, you know, it was really good. I did another example before. All right, let's look at x squared, because I like x squared. Y equals x squared. You guys remember parabolas, right? Now, or let's write this as a function. OK. I can plug. Is there any reason I could not plug in any number in for x? Is there any number I cannot plug in? Real numbers. No, I can plug in anything. You can plug in 3 million. You can plug in 200. For every input, you're going to have an output, right? The domain of this function is all real numbers, negative infinity to infinity, just like that one. It keeps on expanding. Does that make sense? Now, we talked about something over there. There is a value that I cannot plug into this function because it's going to make my what? It's going to make my function undefined. It's going to make my denominator 0, right? You cannot have something being divided by 0. So what is the value that makes this 0? I don't know off the top of my head. Well, 0 is 1. But what you're going to want to do is not always is it going to be apparent, because 0 is not the only number that does that. So what you do is you set your denominator whenever you have a rational function. We're going to be going over more of this next class period. You're going to have homework on this. But whenever you have a rational function, set your denominator equal to 0. Then you go ahead and solve. Now we're going to do factoring next class period. But hopefully you guys remember from here, you can factor out an x, or a 2x. And when you factor out a 2x, you're left with an x minus 4 equals 0. And then we could use the 0 product property. If you totally forget this stuff, don't worry. I'm going to go back over it. But hopefully you do remember. So therefore, we have x equals 0 and x equals 4. So our graph, our solution set, is all real numbers except for the numbers 0 and 4. OK? And we're going to learn this year how to graph this. So then you guys can see what the graph looks like. And it does not contain 0 and 4. Well, I'll show you. Here's where it kind of gets confusing. We got to write the domain, right? So the domain in interval notation, it contains everything except for these numbers. So therefore, it's going to go down to negative infinity, all the way to 0. Union, it's going to go between 0 and 4. Those are not contained because they're not a part of our domain. And then union, it goes from 4 to infinity. It's OK, ladies and gentlemen, if you don't fully understand all of that, we're going to get some more practice in there. OK? But I'd recommend having it written down. Once we do more practice next class period, it should make a little bit more sense. OK? But don't worry right now if it's like, what the heck?